Solving radical equations. Okay, so this is what a radical equation looks like. An equation with a radical in it. Surprise, surprise. Okay, so one thing you want to do is isolate the radical. So we're going to get the square root by itself. So that means we got to move the 9. And once we got the square root isolated, then we square both sides. Right? When you square a square root, the square root goes away. Square root of 7, well, 49. Now just solve like normal. Boop, boop, n equals 6. But we're not done. We got to make sure this works. Now, one of the problems with this technique is that the answers you get don't always work. Okay? Yeah, so we got to check it out. So n equals 6 is the potential solution. So we plug it into the original equation. Make sure you plug it into the original equation. Okay? 8 times 6, blah, 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 blah. 8 times 6 is 48, plus 1 is 49. Square root of 49 is 7. 7 plus 9, 16. So that checks out. Now we accept the answer of n equals 6. Right there. Okay. All right. Here's another example. You got square root on both sides. Square both sides. In fact, this is relatively simple, right? The square roots go away, and I just set the insides equal to each other, and you solve it. You get x equals 4, right? 3 minus 2 is 1, so you got x over here. Negative 1 plus 5 is 4. That's it. Check the answer, right? Plug it in. 3 times 4, 12, minus 5. 2 times 4, minus 1. That's 12 minus 5 on the left, 8 minus 1 on the right, and they both turn out to be square root of 7. So it works. Oops, I forgot to mention that it works. Okay, so the answer was whatever it was, x equals 4. All right, now here, same thing. We're going to square both sides. So here, the square root goes away, and you get k squared. Now, whenever you have an exponent, you want to move everything to one side, right? Set it equal to 0. So what I did was I moved the 2k to the right, making it plus 2k, and then move the minus 1 to the right, making it plus 1, and then flip the whole thing over, right? K squared plus 2k plus 1 equals 0. Factor and solve, right? K plus 1, so we get k equals negative 1. Check your solution. We're going to plug it in. All right, that's the negative 1 minus 2, k is negative 1, and k is negative 1. Well, look at that. So I have a square root equal to a negative number. That doesn't work. Square root is not going to produce a negative number. So that's impossible, so no solution. All right, so here's the thing. K equals negative 1 was the only possible solution. K equals negative 1 was the only possible solution. If we have to reject the only possible solution, then there is no solution. So my head's covering the word solution here. Okay, I forgot my head goes there. Okay, moving on. So here, again, square both sides. Now be careful here. When I square x minus 4, that's x minus 4 times x minus 4. When you multiply a binomial, you get a trinomial. You should know this by now. All right, now move everything to the left. Right, negative 8 plus 6 is negative 2. 16 minus 79 is negative 63. Factor. When I factor this, I get x equals 9, x equals negative 7. Okay, check the solution. 9 and negative 7. Plug 9 in. 9 minus 4 on the left. 79 minus 6 times 9. Work that out. 9 minus 4 is 5. 6 times 9 is 54. 79 minus 54 is 25. Take the square root. 5 is 5. So that works. So x equals 9 works. Let's plug in negative 7. Uh-oh. Bad sign here. Negative 11 equal to a square root. That's probably like 121. But it can't be negative 11. So you reject that one, right? You can't. So we reject the x equals negative 7. And my head's covering the actual answer. It's x equals 9 is the only solution. So we rejected x equals negative 7, but we accept x equals 9. X equals 9 worked. Okay, here's another example. Now, so we're going to square both sides again. And this is what happens. So I'm treating this like it's a binomial. That's one term, and this is another term. right? So if I square the negative 5, I get positive 25. If I square the square root, I get 4 minus n. Now this middle term comes from the squaring binomial shortcut. The squaring binomial shortcut goes negative 5 times negative root 4 minus n times 2. Whenever you square anything and the third term comes out by multiplying by 2, multiply negative 5 times negative root 4 minus n times 2, and that gives you the 10. It's always times 2, times 2, times 2. All right, so that's where that 10 comes from. Okay, and guess what? We got to square it again. So that means we got to get rid of the 4 minus n, and we got to get rid of the 25. All right, so here, 5n plus n. That's where the 6n comes from. 5 minus 25 is negative 20, and then subtract 4 more. So that's negative 24. Now, we usually isolate the square root. So generally, we'd have to get rid of the 10. But if it's multiplied with the square root, it's actually okay. You don't have to get rid of it. And in fact, I don't want to get rid of it because if I divide by 10, I'm going to get fractions. And fractions is not fun. All right, so I'm going to go ahead and square both sides. So remember, this is the shortcut for squaring a binomial. 6n squared is 36n squared. 24 squared is 576. The middle term comes from 6n times 24. 6 times 24, what is that? That's 144. And then times 2 is 288. Okay, now go ahead and distribute that 100 on there. Right? Oh, where did this come from? If I square the 10, I get 100. And square the square root, I get the 4 minus n. So that's where that side's coming from. Go ahead and distribute the 100, and that's what that is. Nothing happened on the left. Move everything to the left side. Notice this is even, and it turns out you can divide by 4. Okay, well there's the last line of the last screen. Divide by 4, and I get this. This is just a difficult factor problem. Okay, hopefully you figured it out. So this is the factor form of that, right? 11 times 4 is 44. 9 times 1 is 9. Inside is negative 11. Outside is negative 36. Negative 36 minus 11 is negative 47. All right, set each factor equals 0 and solve. Bad news. Neither of those answers work. Right? If you plug in 4 here, and by the way, I just didn't do the plug-in part. If you plug in 4 here, you get negative 5. That goes to 0. Square root of something, square root of whatever can't equal a negative 5. So boom. Okay. And in fact, if you plug 11/9 in, that still doesn't get rid of this negative 5. So it turns out we could have just looked at it and said, oh, there's no chance for this to have a solution. So, oh well. All right. That's it. That's it. I'm done. I'm good. I'm done. Good night. All right. So this is the same as today's lecture. And hopefully you don't need to watch this.